Let's start with the ideal gas law, which says pressure times volume is equal to the number of moles times the universal gas constant times temperature. Let's move all the constants to one side. The only two variables that are changing here are pressure and temperature. So we're going to move temperature over to the left side by dividing through by T. So P over T. And we're going to move volume to the right side because it's a constant. It's going to be NR over V. Just divide through by volume. Right, and because this right side on the right is all not changing, they're constant, we can say that any changes to the left, like P1 and P1 over T1, is going to equal that proportion after the change, P2 over T2. All right, let's rearrange this to solve for what it's asking here is what temperature. We're solving for T2, so we can cross multiply. That's going to be one side of our new equation, and that diagonal will be another side, the other side of the new equation. T2 is going to equal to T1 P2 over P1. Before we can plug these numbers in, we're going to need to add 273.15 to Celsius. To turn that into a Kelvin, it's going to be 313.15 Kelvin. The other thing is we can't have two different units of pressure, so let's just turn this into atmospheres, or you could turn it into millimeters of mercury. Doesn't matter, get the same answer. I'm going to turn it into atmospheres. You can do it the other way and see if you get the same answer. The value, I'm going to use the conversion factor, 760 millimeters of mercury is equal to 1 atmosphere. All right, I want to get rid of millimeters of mercury, and I want both my units of, or both my measurements of pressure in atmospheres. 464 divided by 760. It's going to give us 0.6105. I have it stored in my calculator. Atmospheres. Let's go back to our problem. Our initial temperature is P2 is 1.31 atmospheres. P1 is the one we converted, 0.6105 atmospheres. Atmospheres cancel out. All right, let's finally punch these numbers in. How many sig figs? 3 significant figures. 672 Kelvin is our answer.